In this 7th podcast, we're going to look at an introduction to chemical formulas and reactions. In the last lab called Forensic Science Lab, we were trying to identify mystery white powders by adding known liquids to them and looking at the changes that occurred. And the changes that we saw happen were, some were physical changes and some were chemical changes. For example, salt, when we added water, the salt dissolved. Now this is a physical change because the individual water and salt particles don't change. If you drink that salty water, well, it tastes salty. The salt hasn't changed inside the water. An example of a chemical change that we saw was when we added hydrochloric acid to the baking soda, it fizzed. Now fizz is a release of gas. Now, and because gas wasn't originally present, we had solid baking soda and liquid water, chances are we're probably seeing a chemical change taking place. Also, some of you noted that the mixture warmed up, so heat energy was released, and that's more evidence that a chemical reaction was taking place. Now we're going to look in more detail at one of the substances that we were investigating, and that's baking soda. Baking soda is a very common household substance used as a raising agent in cookies and things like that, but also used for cleaning and deodorizing fridges. It's got many uses. Now, what's in baking soda? It's a white powder, but that doesn't really tell us what's in it. The words baking soda don't really tell us what's in it either, but fortunately baking soda has other names as well. And if we look on the chemical on the container which has the baking soda in it, we can see that another name for baking soda is sodium hydrogen carbonate. A very long name, but a lot more meaningful to a chemist. We can look at that and we can start deciding what's inside sodium hydrogen carbonate. So, sodium is inside sodium hydrogen carbonate. Hydrogen is inside sodium hydrogen carbonate. And carbon is inside sodium hydrogen carbonate. But what about the 8? Now, I don't know any chemicals or any elements called 8, but the 8 must have a meaning too, and it does, of course. So it's made up of sodium, hydrogen, carbon, and the 8 tells us that we have oxygen present too. So we have sodium, hydrogen, carbon, and oxygen present. So we've got sodium, hydrogen, carbon, and oxygen present in sodium hydrogen carbonate. And we can write that in a shorter way, a shorthand form. So sodium hydrogen carbonate can be written NaHCO3. Na is the chemical symbol for sodium. H is the chemical symbol for hydrogen. C is the chemical symbol for carbon. And O is the chemical symbol for oxygen. Remember, the 8 relates to the oxygen. There's a 3 after the O. Now that 3 tells you there's 3 oxygens in this chemical compound. There's no number after the C. That doesn't mean there's no carbons. It means there's one carbon atom in this compound, 1 hydrogen atom in the compound, and 1 sodium atom in the compound. So this shorthand version is telling us a lot about the sodium hydrogen carbonate compound. Let's look at some other examples. Hydrogen chloride. This is the substance, when dissolved in water, becomes hydrochloric acid. Hydrogen chloride. Hydrogen, chloride. And there's no 8 there, it ends in an "ide." Well, it's telling us that there's no oxygen present, there's just hydrogen and chlorine present there. Another example, water. Let's call it hydrogen oxide because water won't really tell us what's in it. Hydrogen, oxygen, oxide. The chemical symbols tell us how many atoms of each substance there are. H2O, 2 hydrogens, and only 1 oxygen. Another example, carbon dioxide. Carbon, oxide, it's telling us there's oxygen, but di is telling us there's 2 oxygens. Chemical formula would be CO2. So let's go back to the baking soda, the sodium hydrogen carbonate. Now, one of the reactions we observed was adding hydrochloric acid to the baking soda. Now, there was a chemical reaction, so we saw fizzing and we felt heat being released. So in a chemical reaction, the original reactants rearrange themselves into a, let's say, more stable situation. And at the end, the products that we get are different. We don't have baking soda anymore, and we don't have hydrochloric acid anymore. It's very different to the situation where salt is dissolved in water, because after salt is dissolved in water, we still have the salt in the water. We could still get the salt out of the water. We would just leave it in the sun and the water would evaporate and we'd have salt again. But not so in a chemical reaction. We have fundamental changes going on. The atoms in the baking soda and the hydrochloric acid are going to be rearranged. Now, one of our main observations was that the mixture fizzed a lot. Now, that's a good clue as to one of the products that is made. It's a gas. We're not sure what it is, but we know that one of the products is going to be a gas. It's important to remember that chemical reactions don't create matter, and they don't destroy matter, they just rearrange it into another stable form. In the products, you must have the same number of atoms that you started with. Now, this is where your chemical formulas come in very handy, because the chemical formulas tell you exactly the number of atoms you've got in your substances before the reaction takes place. Now here, what we have are the reactants written down in a chemical formula fashion. We've got the sodium hydrogen carbonate here, and we've got the hydrochloric acid here. In my chemical equation, I've got them written together with a plus symbol because I'm adding them together. The arrow symbol is showing what happens after the chemical reaction. Now we have a gas, and the gas must come from the reactants. We've also got other substances present as well. Now, if we were to taste the products of this reaction, which we should never do because it's a chemistry lab and we don't know what we're dealing with possibly, but if we did, we would notice that we would have a salty tasting water. Salty tasting water that's released a gas because it's been fizzing. And we look at the reactants and we can possibly see that the salty taste is coming from the sodium chloride. So the particles, the atoms, have rearranged themselves to produce sodium chloride. There's the sodium, and there's the chlorine, NaCl. The water must come from here as well. Water, H2O. Here's the H's, and here's some oxygens, H2O. And the gas that's released is, or must contain, carbon, because carbon is left over. So the gas that's released is most likely to be carbon dioxide. So these are the likely products from our reaction. But hold on a minute, let's take a look at this, because we've got to make sure that every atom is accounted for in this reaction. We've got to make sure that for every atom here, we have the corresponding atom here. Remember, they've just rearranged, we haven't made anything new. So we have one sodium here, one sodium on the right. We have two hydrogens on the left. There's our two hydrogens on the right there. We have one carbon on the left, one carbon on the right, and finally three oxygens on the left, where we have one here and two here. So everything matches up. So this chemical equation is balanced and the reaction